All right, Pre-Cal 30, let's check out Chapter 1.3, Combining Transformations. So, we've learned about transformations before. We've studied the shifts, where we're adding and subtracting. Right, shifts like this where we move it around, we have to remember that when it's attached to the variable, we do the opposite. But when it's on the other side of the variable, we do the same thing. Right, these are our transformation mappings when we're stretching. It affects our domain and range. We didn't just do shifts, we also did reflections and stretches. So multiplying or dividing by negatives is flipping. Multiplying or dividing by numbers is stretching. So right here, we had this 2x in front, this 2 in front. So we took our y and we times it by 2. We had the 1/2 in front, so we took our y and we times it by 1/2. When it's attached to the x value, we do the opposite. We're timesing the x by 2, so we divide it by 2. Here we're times it by 1/2, so we multiply by 2. We do the opposite when it's attached to the variable. All right, so what happens when we have to do more than one transformation at a time? Some transformations are adding and subtracting. Others are multiplying and dividing. Do you think it matters which transformation are performed first? Yes. Think about bed mass. Dividing and multiplying, these are stretches. These are shifts. Stretch before you shift. Shift is moving around, stretching is stretching it out. So stretch before you shift. Describe the combination of transformations that's applied to the function y is equal to f of x to obtain the transformed function. Sketch the graph showing each step. So here's our original graph. This is y equals the square root of x. Now we are going to apply these transformations. 3, this is a vert stretch. Remember, with our vertical stretch, because the value is not attached to our vertical variable, we just do the exact thing that it is. We take our y and we times it by 3. This is a horizontal stretch. Because it is attached to our variable, we instead of multiplying by 2, we divide by 2. So we're going to do x divided by 2. So here is our transformation mapping. In our original, we start with y is equal to the square root of x. We have an x and a y value. We are going to transform it to y is equal to 3 square root 2x. And that's going to map to, we take our x's and we divide it by 2, and we take our y's and we times it by 3. So when we start with a point at 0, 0, we map it over to our new point. We do 0 divided by 2 is 0, and 3 times 0 is 0. We call this an invariant point. It did not move. We take our next point, which is 1, 1. It will move to 0.5 or 1/2. I prefer to leave it as a fraction. 1/2, 3. So if I graph that on here, it'll be 1/2, 3. Way up there. No, not even there. 1/2, 3, way up there. I take my point of 4, 2. Take my x value divided by 2, and I go to 2, 6. No, 9 times my y value by 3. Now this doesn't even fit on my little graph here. What would be good to do is you're going to check this on Desmos. I cannot check this on Desmos in the screen recording because it will cancel the screen recording if I do that. Then we go to 9, 3. And that will go to 9 over 2, comma. Oh, this one. This one back here was a mistake because it was 2 times 3. Right? 2 times 3. That should be 6. You can see here, these are now our transformed points. And you can just go and you can graph that on Desmos. You can graph both of these on Desmos and see if these points are proper. I did square root x, and then I did y equals 2 square root 3x. And I can check the different points by dragging my mouse around. 1/2, 3. So I put x equals 0.5 into Desmos. I'm not getting the right answers here. Oh, I see why. I typed it into Desmos wrong. 3 and 2x. Now I get the correct answers. Yes, we did this correctly. All right, let's take a quick look at this second example. Again, we're starting with, we're starting with y equals the square root of x, which is our x and y. And these are the points 0, 0, 1, 1, 4, 2, 9, 3. We are going to this function. Y is equal to the square root of 3x plus 6. But now there's an important part here, okay? This 3 is going to be a horizontal stretch. This 6 is going to be a horizontal shift. But it's not going to go left 6. What we have to do is, when it's all attached to the variable like this, we have to factor out so that our x is by itself. So our f of x, 3x plus 6, we have to factor out so that our x has a coefficient of 1. This becomes f of 3x plus 2. Now this is our horizontal shift. That is our horizontal shift. So in our new one, we are going to take our x, we're going to divide it by 3, right? Because here we're multiplying by 3, so we do the opposite. And then we're going to subtract 2. Here we're adding 2. Here we're adding 2, so we're going to do the opposite. Now there's nothing outside the function, so our y is going to stay the same. So now let's look at our new points. The point 0, 0 is going to go to 0 divided by 3 is 0, minus 2 is minus 2, 0. Now 1, 1. We are going to do 1 divided by 3 minus 2, which is 1/3 minus 2, which is negative 1 2/3. and 1. Our y's did not change in this one. Now we're going to do 4. So we're going to do 4 divided by 3 minus 2. That's negative 2/3, comma 2. For our last one, we are going to do 9 divided by 3, comma 2, or subtract 2. Sorry, 9 divided by 3, subtract 2, which is 1. Those are the new points of our new translated graph, transformed graph. Now, I'm just going to go check that on Desmos, and you should too right now, even though I can't show you. I'm going to type in the square root of 3x plus 6. I'm going to type it in the way that's given to me. And I get negative 2 and 0. So I just check. That one is correct. Now I can just put x is equal to 1 in as well and check that one. X is equal to 1. This one is also correct. The other ones are harder to check, but I think I can. Negative 2 over 3. And I get 2. This one is correct. So you can check them on Desmos that you did this correctly. All right, so important things to remember. When you're doing multiple transformations, we stretch before shifts, and you need to factor so that the coefficient of x is a 1 in order to determine the horizontal shift. All right, we'll look at an example in the next video.